Good day, everyone. So we will continue now our discussion from the previous micro video lecture. Okay, so let's go with resistance. Now, it says there that resistance, it may be defined as the property of a substance due to which it opposes or restrict the flow of electricity through it. Metals as a class, acids and salt solutions are good conductors of electricity. Amongst pure metals, silver, copper, and aluminum are very good conductors in the given order. Now, this, as discussed earlier in our previous lecture, uh, this is due, this is due to the presence of a large number of free or loosely attached electron in their atoms. When you try to go back to your chemistry and I guess until physics, this has had been discussed, no, regarding the valence electron of a conductor. These vagrant electrons assume a directed motion on the application of an electric potential difference. These electrons, while flowing past through the molecules or the atoms of the conductor, collide the other atoms and electrons, thereby producing heat. Okay. Now, let's proceed with this one. Those substances which offer relative greater difficulty or hindrance to passage of these electrons are said to be relatively poor conductors of electricity, like bakelite, mica, glass, rubber, PVC, and dry wood, etc. Amongst good insulators can be included fibrous substances such as paper and cotton when dry, mineral oils free from acids and water, ceramics like hard porcelain and asbestos, and many other plastics besides PVC. It is helpful to remember that this friction is similar to friction in mechanics. Now, the practical unit of resistance is ohm. A conductor is said to have a resistance of 1 ohm if it permits a 1 ampere current to flow through it when 1 volt is impressed. Remember, I talked about earlier about the 1 volt, no? That there is an impressed voltage that and that's the reason why current is flowing. Now, the ohm is the measure of the opposition, or may I say, the opposition of the current flow. Now, a resistance of 1 ohm, if it permits 1 ampere of current to flow through it, okay, when 1 volt is impressed. And this unit was named after George Simon Ohm. Now, for insulators whose resistances are very high, a much bigger unit is used. Example, for mega ohm is 10 raised to 6, or kilo ohm for 10 raised to 3. In the case of very small resistances, smaller units like milliohm as 10 raised to negative 3, or micro ohm as 10 raised to negative 6 ohm are used. And the symbol for ohm is this one. No? It's like the capital omega. The capital omega in the capital omega in Greek. Okay? Now, the resistance R offered by a conductor depends on the following factors. First, it varies directly as its length L. It's not a multiple choice, ha? But these are the important details. Next, it varies inversely as the cross section A of the conductor. Next, it depends on the nature of the material, and then it also depends on the temperature of the conductor. Now, since we're going to discuss first the resistance itself, let's neglect first the last factor, or the temperature. Neglecting the last factor, we can say that R is directly proportional to L over A, or R is equal to rho. This is the Greek character rho, and this is not a density, but what? This is the specific resistance or resistivity of the material. It depends on the material itself. Now, what can we notice regarding the formula? Since this is directly proportional to L, the longer the conductor, Okay, the longer the conductor, the higher the resistance, di ba? And the area naman is inversely proportional. So the lower the area, the higher the resistance itself. Okay? So that's our first formula. Now, let's proceed with this one. This is the units of resistivity. I told you earlier that this depends on the material of the conductor itself. So, here are the units of resistivity. We have the aluminum, brass, carbon, the constantan, copper, anil copper, the German silver, gold, iron, the manganese, mercury, the nichrome, nickel, platinum, silver, and tungsten. You can copy this one, post the video, and then copy this one. Okay. And let's proceed with some of the problems given for the resistance. Also, we have this one. These are used for insulator or dielectric. Amber, bakelite, glass, mica, rubber, the shellac, and then the sulfur. Okay. So let's proceed. Next question is this, number 3. It says there, a coil consists of 2,000 turns of copper wire having cross-sectional area of 0.8 square millimeter. The mean length per turn is 80 centimeters and the resistivity of copper is 0.02 microohm meter. Find the resistance of the coil and the power absorbed. The power absorbed, no? By the coil when connected to 110 volts DC supply. Okay. So, we need to remember this formula. That we're using what? R is equal to rho. It's rho times L over A. Okay. Now, for the rho, it's 0.02 times 10 raised to negative 6 in ohm meter. Okay, remember this one is rho, that quantity itself. This is the resistivity or the specific resistance. Okay, sabagay, it was told naman in the problem. Okay, and then the length is we have there 0.8 square millimeter. Actually, it's the area itself, but the mean length per turn is 80 centimeters. When you say mean length, example, we have this one. The coil is, let's say, it's looped in this way. Okay. Tawag ko dito, no? When you say it has a mean length of 80 centimeters, meaning the mean length per turn, meaning to say every one turn of it, every one turn of this one, they try to get the length and then take the average. But for a coil of wire, it's equal, no? So what we only need to do here is to get the length in this way. 0.8 I know it's 80 centimeters. Can I diretso, no, convert it to meters? So 0.8 meters, 80 centimeters, 8 centimeters is 0.8 meter, and then multiplied by what? How many turns? Actually, it's 0.8 meter per turn, and then we can multiply it by 2,000 turns. By the way, number of turns is basically, it has no unit, but we can use that one to eliminate, no, and to see the relationship between the values. All over what? All over the area. Okay? The area there was, yan na pala. It was 0.8 square millimeter. So we can now multiply this one to 1,000 millimeter is to 1 meter. squared. Okay? So to convert that fully to meters, so we can now multiply this one turns, and then after that, there's another meter here, so we can eliminate it from here, but it needs to be multiplied from this one. There's another meter here, canceled out for this, with respect to the meter above. Okay? So, the resistance given to us is 40 ohms. Now, the power absorbed is P is equal to, this is the resistance itself. Find the resistance of the coil. Tapos, and power absorbed. For the power absorbed, okay, this is P is equal to V squared over R, and that itself is 110 volts squared over the resistance of 40 ohm. Okay? So that's it. We can get this one as 302.5 watts. So this is your the power absorbed. Okay? So that's it. Okay, next to it is this. Number 4. An aluminum wire 7.5 meter long is connected in parallel with a copper wire 6 meter long. So meaning to say, there is a particular aluminum wire and it is connected to a copper wire. Now, this one is aluminum, copper. Okay? Tapos, when a current of 5 ampere is passed through the combination, okay, so that passed through the combination itself, it is found that the current in the aluminum wire is 3 ampere. So meaning to say, let's say it's connected to another part of the circuit. Of course, we assume that there is a pushing force here, there's a voltage here. Kasi that voltage will push the current. Now, when a current of 5 ampere is pushed through the combination, it is found that the current in the aluminum is, let's say this is I1. This is 3 amperes. Now, the diameter of the aluminum wire is 1 millimeter. Then determine the diameter of the copper wire. The resistivity of the copper is 0.017 microohmmeter. Then that of the aluminum is 0.028 microohmmeter. Okay, just to give you an insight, I want to express this one using ratio and proportion. Okay? Let's say for aluminum it's R sub 1 and for copper it's R sub 2. So R sub 1 for aluminum density resistivity 1 times L1 over A1, and for the copper itself, we are looking for what? For the that determine the diameter of the copper. Okay, we can use the ratio and proportion here. So we can divide both ends. R sub 2 is equal to density 2 times L2 over A2. Okay. So, I guess, as we invert this one, we can get this relationship. R2 over R1 is equal to density 2, resistivity 2 over resistivity 1 times length 2 over length 1. But for the area, it's inverted. Such that we have area 2 over area 1. Okay? Now, kasi we are looking for the diameter, so it's better for us to get the area instead. Okay? So, now things that you need to remember here. we were given there a current of what? At an I total of 5 amperes. So, we can get your I sub 2, no? Now, from the circuit shown, the value of your I sub 2 is simply 5 amperes minus 3 amperes, which is 2 amperes, right? Okay. Tawag ko dito, no? Regarding the parallel circuit, you already know this one because of physics. But for this part, you know that the voltage in the aluminum is same as the voltage in copper. Therefore, we can have there I1R1 is equal to I2R2. Okay? And what I need here is just what? The ratio. Okay? So I need the R2 over R1. R2 over R1 is I1 over I2. And apparently, I1 is 3 amperes over 2 amperes. So we'll get there R2 over R1 as 3 over 2. Okay? Ngayon, from the equation that we have there in black, we can now continue this one. Now, what do we need ba? The determine the diameter of the copper. The diameter of the copper wire comes from A2, area 2. And that itself is R2 over R1 times rho 2 over rho 1 Oh, I guess it's inverted. I think it should be area 1 over area 2. Yeah. Sorry for that. Okay. I'm inverting it pala. So area 2 is now R1 over R2, rho 1 over rho 2. And then we have there area 2, no? Ade, rho 2 over rho 1, L2 over L1 times area 1. Okay, that's it. So, we now have there this one. Rho 1 over rho 2 is just the reciprocal of this, which already is 2/3. Ang rho 2 over rho 1, rho 2 over rho 1 is this. For the copper, 0.017 microohm per meter. Pero it's okay na to put the unit because it's ratio in proportion. 0.028. And then the length is 7.5 meter long for the aluminum. So L sub 2 is 6 over 7.5. Okay? As long as they are what? In the same unit, no? You don't need to convert them. And then A1 in the end. A1 is pi over 4d squared. The diameter of the aluminum wire is 1 mm. But we can have there, sige, let's put this one in mm. Okay, squared. So let's get A sub 2. Okay. After that, we'll get 0.2544 mm squared. Now, after this, we'll go with this. That area 2 is the same as pi over 4 d2 squared. Okay, that's where we're going to what? That's what we're going to use to find the diameter of the copper wire. Okay, the area 2 is 0.2544 square millimeter times 4 over pi, and since that's in square millimeter, we need to take the square root. Okay, Now, the diameter 2 becomes its 0.569 millimeters. And this is what? This is your answer for this item. Okay? So thank you very much for listening to our micro video lecture. So we'll continue the next problems in the next videos.